Signs on the ordered pairs are they the x or the y value? The y value, very good. The sign ordered pair is the y value. So you start at 0, sign starts at 0. At pi over 2 it goes to 1. At pi it's back to 0. At 3 pi over 2 it's at negative 1. And then at 2 pi it goes back to 0. So as we go around the circle, if we plot that out via a regular standard XY graph, what happens is, sign starts at 0. At pi over 2, it goes to 1. At pi, it's back at 0. At 3 pi over 2, it reaches its minimum at negative 1. And then at 2 pi, it goes back to 0. So you've seen this, and I think I've drawn this curve for you guys a couple of times. The sine curve will always, always, always look like that. What happens is you have what's called a periodic function. It repeats itself every single time after a certain amount of what's called a period. The period of sine would be considered 2 pi. It takes 2 pi length to go through one full cycle of the graph. If I extended this graph on to 4 pi, it would have just repeated the exact same curve, and over and over and over again. Because as you go through, you get the same exact, what I call breakpoints, 1, 2, 3, 4, 5, which work out to be your quadrantals. We look at the quadrantals because they're easy to work with. Zeros and ones. And that's how you just follow yourself through. Now, if you got fancy with it, and you looked at it at, what would that be? If I put this at pi over 6, at pi over 6, sine is what? 1/2. So it would have been here. At 5 pi over 6, it would have been at half. At 7 pi over 6, it's at negative half. At 11 pi over 6, it's at negative half. But those get messy. There's too many 6's and stuff to move around with that. That's why we use the breakpoints of 0, pi over 2, pi, 3 pi over 2, and 2 pi. It's a very easy way to do it. Okay? Not bad. Cosine, on the other hand, is basically the opposite of that. Cosine graph, as you think about the unit circle, cosine at 0 starts at 1. At 0, it's 1. Pi over 2, it's 0. At pi, it's at negative 1. 3 pi over 2, it's back to 0. And then at 2 pi, it goes back to 1. So the cosine graph, if you look closely at it, is just a sine graph shifted 90 degrees. It's just moved over 90 degrees. That's where it would have been up there. It's just moved over 90 degrees to make it work. That's your basic idea for a cosine graph. Again, it's a periodic function. It goes through a cycle. It has maximums, it has minimums. It has a specific period. 2 pi is your standard stuff here. Okay. I know that I've kind of alluded to this a bunch of times in class. So this doesn't look like such a great shot, is it? What's going to happen, though, is that not always will everything look so cleanly. Sometimes you'll have to worry about gang signs. I want that as a t-shirt. Who's in graphics? Anybody in graphics? Can you make me that? What do you want to now? Like sweatshirts?
You only have one year. You can order that for graphics though.
Yes, I will do that. How much is a t-shirt? Is it like $12?
No.
Alright. So here's what happens. This is where all the nuts and bolts of this comes from. We're going to break this up into writing it out in terms of y equals a sine b of x and y equals a cosine b of x. These are going to be what we're going to call parent functions, non-shifted parent functions. And we'll move these things left and right, up and down tomorrow. But what we have to be able to do here is look at it in terms of what are called amplitudes and what are called how do you find the period. Because not every time are you're going to have a graph that's just y equals sine of x. Probably. Thanks. Still geometry. So, here's what happens. You have y equals a sine b of x and y equals a cosine b of x. This value of a is what you call your amplitude. What that means is how high up or how low it goes. It tells you direction. If a is positive, sine starts at 0 and goes up. If a is negative, sine starts at 0 and goes down. It tells how high, low it goes, and direction. The direction via its sign. Okay. And it gets really easy as we get into this stuff. This b value, it determines period. With sine and cosine, the generic sine and cosine is a standard period of 2 pi. What we do though is that we have a b value, like a multiplier, if you will, that gets thrown in. And if you have this multiplier getting thrown in there, you take 2 pi over b, and that will determine your period that you're going to work with. And I'll show you guys how we're going to create breakpoints given some weird numbers. And it's pretty quick. So your period is always going to be 2 pi over the absolute value of b. It's going to be very rare that we have a b value that's negative, but you can have a values that are negative. All right? When they talk about the amplitude being with an absolute value like that, that just means the amplitude is always going to be, always think of it as how high up it goes. So if your a value is -4, the amplitude would be 4. The negative is what tells direction, and it depends on sine and cosine how it works for which direction things are going to go first. Okay. And then believe me, it seems like there's a ton of information here, but this is actually one of the easier things in trig to do. Okay. Because you kind of just do the same thing over and over and over again. Why is everybody so gloomy today? It's nice out. It's not raining now. Is it raining now? See, it's nice out then. You guys had a 3.5 day weekend. You should just be happy people. Okay. Where's the one out? Oh, let's do this one. So we'll go. Let's grasp this. Y equals 2 sine of 4x. Now, like we've done in the past where we have had A, H's, and K's, I always like to label those things out. I still like to do that because it'll help you remember a lot of little bits and pieces. So we have an A value of 2, a B value of 4, which means my amplitude is 2, and my period is going to be 2 pi over 4, otherwise known as pi over 2. Very good. So that tells me that my period being pi over 2, it's going to start at 0, go through its whole cycle, and end at pi over 2. That means I have to figure out the breakpoints in the middle. Here's what we do. I always work with the exact same graph every time. I draw this little sideways T-chart because I think it's the easiest way to do this. I know that I have a 0 because it starts at 0, and I know it's going to end at pi over 2. What I do now is place everything in the middle. What's half of pi over 2? Pi over 4, very good. What's half of pi over 4? Pi over 8. So now, if you think about it, you start at 0, 1/8, 2/8. What's the one in the between the next one? 3/8. Because pi over 2 is 4/8. What happens is, by taking this period value, knowing that it ends at a half, all you're doing is cutting it in half twice and adding back to the third spot. Okay? It just looks weird to do it that way. You do it a couple times, it's really quick. And don't worry, you're not going to get really crappy fractions. You're not going to have to worry about like 3/16ths. Well, that's not bad, but things like that. Like 13ths as a denominator. Your denominators are generally going to be halvesies and eighths and sixths and stuff like that. They don't work out to be too terrible. Okay. So, excuse me. Our A value was 2, which means how high up is the sine graph going to go? It's going to go to 2. And it's going to go down to -2. Which means, yes, sir?
Didn't you say like it was the absolute value? So
Yeah.
like,
So
you
what's
don't know
the absolute value of 2?
Can it be -2 or 2? Or,
Absolute value just means distance from 0. So if your A value is -2, how far away is it from 0? 2. If your A value is +2, how far away from 0 is it? 2. Absolute values are always positive because distances are positive. The negative part of it just tells me direction. If my A value was negative, I wouldn't go up first, I would go down first. That's all that means. It reflects it. So now we know it goes 0, amplitude, 0, opposite amplitude, 0. And there's your graph. What's up? Yes. Yep. Sine graphs always do this. They have the cycle for sine graphs. The sine graph will always start at 0, 0. The next point will always be whatever 1/4 your period, but I'm just going to leave that blank, but I'm going to say it's going to go to your A value. The next one's going to be at halfway and 0. The next one is going to be 3/4 away and the opposite of A. And the last one's going to wind up at 0. The Y values for your sine graphs will the sine always starts at 0. It goes to your A value. The next one is at 0, opposite of A, and 0. So if this A value happened to be negative, if my A value was negative, my amplitude is still +2, but it just means that I go from 0 to -2, 0, +2, and 0. And I just reflected the other direction. That's it. That's all the A value does. It just reflects it over the axis. Okay. What's up? All right. Not too bad, right? Now, the cheat sheet then for cosine, cosines are just all these things rotated over 90 degrees. And then it always follows the same pattern. Okay. Now, I don't like writing these out all the time. I think it's easier to do breakpoints and just plot them. It's a little less cumbersome. There is an advantage to writing out ordered pairs, and that comes in tomorrow when we shift things. Because we'll have to add left and right and subtract and stuff like that. But we'll worry about that tomorrow. So far, so good? You guys are just so bad. All right, so let's do this. Y equals 1/3 cosine of pi x. We'll graph that one. We'll go through the same idea as far as A, B, amplitude, period, all that kind of fun stuff. All right. What's your A value? 1/3. What's your amplitude? 1/3. What's your B value? Pi. That means your period is going to be 2 pi divided by pi, which is 2. Same old, same old. Where are your breakpoints? What's half of 2? 1. What's half of 1? So used to writing pi over 2. And then what's going to be between 1 and 2? 3 halves, here we go. Cosine, remember, always starts at its A value. The cosine starts at its A value. The A value here is 1/3. It will rotate itself through to its opposite A here at negative 1/3. Do I need to make these graphs scaled the same? No, there's no reason to, because it does not matter. Just draw it. That way you'll start to see that every one of these graphs kind of looks the same. It's a matter of labeling out your points correctly. That's where everything comes into play. If you can label things out, everything else goes. So cosine. Oops, I don't know why I put a 0 there. Cosine always starts at its A value, and it rotates through. And there's your curve. Oh, this is very exciting. Why aren't you guys ever awake? Do I need to like dance or something? Wait, not. I need negatives. I need negatives. It's gotta be 1. Let's graph this one. Y equals -2 times the cosine of 1/12 x. You do. What do you think the first thing I'm gonna ask you to identify? A, you're right. What's A? A is -2, which means my amplitude is 2. My B value is how much? 1/12, which means that my period is going to be 2 pi divided by 1/12. When you divide by a fraction, what do? Multiply by its reciprocal, therefore your period is 24 pi. Okay, so we have a 24 pi period. So I end at 24 pi. What's half of 24 pi? That's right, 12 pi. Very good. What's half of 12 pi? 6 pi. And what's between 12 and 24 then? 18. Got my breakpoints. Cosine starts at its A value. The A value here was -2. So cosine starts at its A value. This time it's negative. That's fine. It just still rotates through the other points. So you have now a reflected cosine graph. Yes, ma'am. Just by literally that. Cosine will always start at its A value, whereas sine always starts at 0, then goes to its A value.
Oh, I meant, how do you know if it starts at negative or positive?
From the problem. See, in this case here, we had a negative A. Since it was a negative A and it's cosine, that means it starts there. Okay. So really the only tip or trick that you need to remember then is that sine starts at 0 and then goes to A. Cosine starts at A and goes to 0. That's it. That's why a couple minutes ago when I started writing out those ordered pairs off to the side, the 0 A's and all that, you can do that, but it's messy. I mean, same idea here. You have half your period, your fourth your period, your A, half that. This is so messy and cumbersome to write out. That's why I always thought it was so much cleaner to start by enlisting the period, put out your ending point, cut it in half, put it back in. It's just a cleaner method of doing so. That way you don't get overburdened by all these fractions, because they can get kind of messy. Okay. A values, just remember cosine starts at A and cycles. Sine starts at 0 and cycles to A, whether it's positive or negative. Excited. Yeah, we'll do tangents tomorrow. Or we got shift first. All right, let me use some problems. Because that's all you want. You can care less about practice. Let's see. So sines and cosines. Okay. So this is in 14.2. Oh, I'm sorry, 14.1.
My page?
So I think I skipped. You'll have, there's two of them you'll have to skip, three of them. You don't know how to do, skip any tangents. I think there's three of them that are tangent in there, but it's hard to just, I mean, I didn't want to do all of it at once, sine, cosine, and tangent. Because tangent's so different. It's really easy, but it's just so much different than the other two, and I always like to separate them out. Label your breakpoints though, please. Make sure you label your breakpoints. Don't just draw curves. Bums. Okay? Why are you guys so crabby today? So what? Yes. And then he eats lasagna. He goes to sleep. I think that cat